Okay, let's look at question 7. It's the last question of the June 2019 Limpopo question paper. This question has got some bad grammatical errors in English, but we're just going to zoom past them. The unbalanced chemical equation, this should read 1, the question paper is incorrect. The unbalanced chemical equation 1 and the word equation 2 for two chemical reactions are shown below. So here we have chlorine plus hydrogen goes to hydrogen chloride, and aluminium carbonate goes to aluminium oxide and carbon dioxide. Then it says state the law of conservation of mass. Now the law of conservation of mass is not in the grade 10 and exam guidelines. It is also not in the CAPS document. So there is some leeway here in terms of what you can describe as the law, okay? So if you go to Wikipedia, for instance, it tells you the mass of any one element at the beginning of the reaction will equal the mass of that element at the end of the reaction. So I would probably be willing to accept anything that says the mass of the reactants equals the mass of the products, because that's basically what it is, if you can figure it out. Okay. Now it says to you, which one of the following reactions, 1 or 2, is a decomposition reaction? Remember, in a decomposition reaction, you take something simple and break it down into more things. So like, for instance, if you have a giant buffalo and it dies and then it decomposes, it's broken down by microorganisms into tiny millions of little things. So here's my big buffalo of aluminium carbonate being broken down into aluminium oxide or carbon dioxide. So number 2 is a decomposition reaction. And this means that number 1 is a synthesis reaction because we took two simple things and made them into something more complicated. Chlorine is simple, hydrogen is simple, hydrogen chloride is complicated because it's got two different kinds of atoms. What does the G in reaction 1 represent? It means something in the gaseous phase. So I would accept gaseous phase, gas. Either of those two will work. Now it says to you, write down the chemical formula for the following. Aluminium carbonate. So first of all, we must know that Al is aluminium. And then we must know that carbonate is CO3. And remember, it is CO3 2 minus. Okay, so I'm not going to put the CO3 2 minus in there. I'm not going to put it in my equation, but I want you to remember that the carbonate ion has got a 2 negative charge. Now, if you go to your periodic table and you look at aluminium, aluminium has a valence of 3. It becomes the Al3 plus ion. So if we are Al3 plus and CO3 2 minus, is this neutral? No, because I've got 3 positives for the aluminium and 2 negatives for the carbonate. So what I do is you take the charge from the one and you move it to the other. You do it diagonally. I need to maybe make this bigger. Okay, so if this is Al3 plus and this is CO3 2 minus, okay, you take this charge, which is up at the top here, and then, this charge is up at the top, and you bring the charge diagonally downwards. For instance, let us draw a little arrow. You're going to take this aluminium and you're going to take the charge down to the bottom there. This is a very terrible arrow because we're doing something very small. So what I'm going to do now is I am going to put the carbonate, because it's a polyatomic ion, it belongs all together. I'm going to put this ion in brackets to indicate that it is one object moving by itself. The whole polyatomic ion behaves as one thing, okay? And I'm going to put a 3 down the bottom because I've taken the charge from the aluminium and put it down here. Then I'm going to take this 2 charge and I'm going to put it on the aluminium at the bottom as a subscript because it is now Al2 CO3 2 minus. So if I've got 2 aluminium ions with 3 positive charges, overall the aluminium is giving me 6 positive charges, and then I've got 3 carbonate ions each with 2 negative charges. That gives me 6 negative. So 6 positive and 6 negative gives me something that is neutral. So now I'm going to remove these charges because we don't need them in the final answer. And this is your final answer, Al2CO3 3 times. And remember, this carbonate ion, CO3 2-, is a polyatomic ion, so we have to put it in the bracket to indicate that we have 3 polyatomic ions. Now we do the same thing with aluminium oxide. Remember, aluminium still has the charge of 3. Okay, so this is going to be Al3+, and oxygen is usually 2-, so we're going to do exactly the same thing. We're going to swap the charges. The same way CO3 was 2-, O is 2-, so this becomes Al2O3 for the exact reasons that aluminium carbonate became Al2CO3 3 times. Okay, so this is aluminium oxide. So we've got 6 positive charges from the aluminium and 6 negative charges from the oxygen. Now it says to you, write a balanced chemical equation for equation 1. Like, this is the easiest thing on the planet. So let's take this equation and we'll put it here. Now, at the moment, I've got 2 chlorine atoms on the left, but on the right, I only have 1. How do I fix that? I may not play with the subscripts. I must add a coefficient. So I've added this coefficient here. So now I've got 2 chlorine atoms on the left, 2 chlorine atoms on the right. I've got 2 hydrogen atoms on the left. I've got 2 hydrogen atoms on the right. I have balanced this entire equation for 4 marks by putting a 2 on the right-hand side of the arrow. So for 4 marks, it's usually left-hand side, right-hand side, balancing, and sometimes the 4th mark is for putting in the state symbols, these gas, gas, gas. Now it says use the balanced equation in 7.5 to show that mass is conserved in a reaction. The problem here is that it's this reaction shown in 7.5. Okay, we're going to take this reaction, but the memo has got this aluminium reaction. Okay, so let's do this here. Let's find out what is the mass of reactants. Okay, so this is going to be chlorine, Cl2, so it's 35,5. Remember, where am I getting this mass from? At the moment, out my brain. If you don't have it in your brain, where will it be? On the periodic table. So there's my mass of the chlorine, plus hydrogen weighs 1. Okay, so if you put this into your calculator, 35.5 and 35.5 plus 1, what is my mass of my reactants in your calculator? It gives you 73. Okay, and then we go mass of products. Okay, and now the coefficient is 2, so it's going to be 2 times, what have we got here? 1 chlorine at 35.5 and 1 hydrogen. Okay, so this is equal to 2 times 36.5, and what is 2 times 36.5 on your calculator? 73. Okay, so now for all 5 marks, you can't stop here. You have to say mass of reactants equals mass of products, therefore mass is conserved. Now, whenever you have one of these calculations like this, if the mass of reactants does not equal the mass of the products, you've done something wrong and you haven't balanced the equation properly. So if your mass of reactants is not equaling your mass of products, go back to the previous step, check that you've balanced the equation properly. But this is now the answer for this part, and remember the memo's got it for the aluminium reaction, so the memo is not helpful here. Now it says to you calculate the percentage composition of hydrogen chloride. So to calculate the percentage composition, we need the mass of the hydrogen and the mass of the chlorine over the total mass of the compound. So the mass of hydrogen chloride is equal to hydrogen, which is 1, plus chlorine, which is 35.5. So this is 36.5. So now if that's the mass of hydrogen chloride, the percentage hydrogen is going to be the mass of the hydrogen, okay, divided by or over, you should normally write this as a fraction, but I can't put fractions in here, the mass of the hydrogen over the mass of the hydrogen chloride multiplied by 100, because that's how we get to a percentage, okay. So this is going to be equal to the mass of hydrogen, which is 1, divided by the mass of hydrogen chloride, which is 36.5, times by 100. So if we put this into our calculator, 1 over 36.5 times 100 gives you 2.74%. Remember, 2 decimal places. The exam instructions say you must give your answer to 2 decimal places, so round off your answer. Now we need to find the percentage chlorine, and you see how I'm writing here percentage hydrogen, percentage chlorine. You have to do this, okay? Oopsie. You have to write this. If I don't know what you're dealing with, I can't award you the mark. So I want to know which is the hydrogen, which is the chlorine. So this is the same thing. It's the mass of the chlorine divided by the mass of the hydrogen chloride, okay, times by 100, because that's how we find a percentage, is by multiplying by 100 over 1. So if you have this as a fraction, you can put it as 100 over 1. So the mass of the chlorine is 35.5, so that is over the mass of the total compound, which is 36.5, times by 100. And if you put this into your calculator, can you hear my calculator, you end up with 97.26%. Okay, and so now obvo, these two should add up to 100%. These two values should add up to 100%. So this is the percentage composition for 4 marks. Now it says to you, when sulfur dioxide gas combines with water vapor and air, it forms sulfurous acid. Write down the balanced chemical equation for this reaction. Now this is 3 marks. So now some of you will not know what's the formula for sulfurous acid. You can get at least some of the marks if you know what is sulfur dioxide and water vapor. Okay, so now sulfur dioxide is very obvious. It's sulfur dioxide. Di means 2. Okay, put in your state symbols. It told you it was a gas. So this is SO2. And then we're going to add it to water vapor. I'm assuming you all know that water is H2O and vapor means it is in the gaseous state. Okay. Now, if you know these two, you can get a mark. But you may only get a mark if you prove to me that you know that they are the reactants. Okay, because the sulfurous acid is the product and these are the reactants. So if you just write these down, I can say, okay, well, you think this is sulfurous acid. So the only way you show me that you know that these two are the reactants and not the products is by putting in the reaction arrow. So let me just copy a reaction arrow from here because it's hard to type in. So now I have either got 1 or 2 marks depending on the mark allocation here, okay? Because I have shown you that I know what sulfur dioxide and water are, and I have given you their state symbols, and I've put the arrow to show you that I know that they are the reactants. So bargain, you have some marks. Now sulfurous acid is H2SO3. It is a weak acid. We usually talk about sulfuric acid, which is a stronger acid. And it says to you, I think this is going to be a gas as well. So I've just put my state symbol in there. Now it says to you, write this in a balanced form. So I need to check here. I've got 1 sulfur on this side, I've got 1 sulfur on that side. I've got 1, 2, 3 oxygens on this side, I've got 1, 2, 3 oxygens on that side. I've got 1, 2 hydrogens on this side, I've got 1, 2 hydrogens on the other side. This reaction, as I wrote it, is already balanced. So in any given reaction like this, when it says write down the chemical reaction for the reaction, if you know either the reactants or the products and you don't know the other half, just draw the arrow on the correct side. So I know these two are the reactants and I know this is the product because of my arrow. If you don't put the arrow, you are not indicating chemical change and you will not be awarded your mark.